Hi, my name is Lukáš Doležal and I'm going to talk about R-value references and related move semantics, which are new principles in the new C++ standard C++OX. Did you know that although C++ is considered as the fastest programming language today, performance of programs can be increased by up to 70% only by adding R-value references to the language? Yes, up to 70% increase in performance. And how is it possible? That is the subject of my presentation. So, first of all, I'm going to look at motivation why have R-value references been created. Then, I want to briefly show you what it is. After that, I'll be talking about how to use it in an appropriate way. And finally, I'd like to analyze how it can increase performance of programs. Now, I'd like to show you why have R-value references been added into the new C++ standard. Let's have a look at this. This code just takes two strings returned from some function and concatenate them into the variable a. It is sample of very common practice. So, what is interesting here? Let me show you this diagram. This diagram describes what is actually done by this code when C++ compiles it. You can see there 6 arrows. Each arrow represents one copying of data. It means that for concatenating two strings and putting the result into a variable, your program needs to perform 6 copies of these strings. I believe you can imagine that copying 1 GB string 6 times can last very long. Is it possible to reduce the number of copying the data? I'd like you to look at these 3 temporary objects. They are created by copying result of a function, and they are used only to be copied into another object. So, what will happen when they will not be there? The answer is simple: nothing will happen. So, then you can ask, why do temporary objects are there? Let's have a look at this code sample. It is just a sample of assigning values to variables. Using this code, I'm going to show you why there were temporary objects in the last slide. Please focus on the last 2 lines. On the first line, the content of the variable a is copied into the b. This is assumed behavior because we want to use the variable a with the same content even after changing the content of the variable b. Now, I'd like you to look at the second line. There is exactly the same situation as in the first line, except that on the right side of the expression is a function instead of variable. And here's the problem. The equal sign cannot distinguish between different types of the right side, so it always needs a variable on the right side, and it always do a copy of data, even when it is unnecessary, as in this case. This indistinguishability is why C++ has to create a temporary objects from a result of a function. And this indistinguishability is also the main motivation for adding the grammar to the C++ language, which is R-value references. This brings me to my next point, which is description of what R-value references are. Briefly, the R-value references are the way how to deal with problem I have showed you, how to distinguish between a variable and function on the right side of an expression. The idea is to introduce a new symbol to the language, a double ampersand, which represents an R-value reference, and with it to change behavior of how functions return their results. With R-value references, every function returning a non-reference type is automatically retyped to the R-value reference type. This concept enables you to write different behaviors of a function depending on whether it is processing the variable or R-value reference. As you can see on this slide, there are two similar declarations of assignment operator for the string type. In the first one, the operator knows that assigned content is from a variable, so it has to copy that. In the second, it knows that assigned value is from a result of a function due to the already mentioned concept of R-value references. So the data can be moved instead of copied. This principle is called move semantics and is particular for using R-value references. This brings me seamlessly to my last point, which is how to use R-value references. Using of R-value references can be described by three simple rules. First rule you should follow is don't write double ampersand to return type of a function. As I mentioned before, it is done automatically by C++. Second rule is that when you have a function in which you have copied content of an argument, write also an overloaded version of the function with R-value reference. Then you can move the content of a variable instead copying it. As I said before, this is called move semantics, and it is why R-value references have been created. The last, third rule, is similar to the previous one, but I separated it to make it clear how to use it when working with classes. When you are writing a class, which can be copied through copy constructor and assignment operator, write also the constructor and assignment operator with move semantics. This is very important to achieve benefits of using R-value references. Let's now move on to the description of performance increase by using R-value references. Let me go back to my first diagram. As I explained before, there is done too much unnecessary copying of a data. And now, have a look at this diagram. Almost all occurrences of doing a copy disappeared only by using R-value references. Just 2 of 6 are still there, but they are necessary for making the concatenation. And this brings me to the end of my presentation. To recapitulate, we have discussed where is the problem with indistinguishability of the right side of expressions. Then I have showed you how R-value references solve that problem and how to use them. And finally, we have briefly discussed why R-value references can increase the performance of your programs. Thank you very much for your attention. If you have any question, feel free to write it in the comment section below.